Welcome family. In this tutorial, I will show you column design and detailing from ETABS output as per Eurocode standard for multi-story building. This is final design ready for AutoCAD, what we are going to design together. From the final design summary, longitudinal reinforcement or that of main reinforcement for foundation column that is 10, a diameter of 40 bar, and the other basic point is that critical rigidity and that of non-critical rigidity. This is all about shear reinforcement. Critical rigidity, it is a shear reinforcement for different ductility class. That may be a ductility class medium, low, or that of a high ductility class, but in our case it's a ductility class medium. So we have get diameter of it at 80 millimeter, and that of a non-critical region that is at the middle of the column. We have get diameter of it at 250 millimeter. Let's go back to the first page of this Excel template sheet that is enable to us automatically generate this design summary. Now it's a time for subscribe this channel to get next update free, like this video, and finally drop any comments, maybe your question or suggestion for next. Thank you family for your support. Let's start today's tutorial. As you have seen in the screen, our project is G+4 residential building. That means it is a total of 5 story. Let's make it in developed elevation. So let's go to elevation here. Elevation 1. Make it okay. Let's move it up. From this, let's select one column. Let's select this column. After that, we are going to design this foundation column. So from this area of reinforcement is 1200 millimeter, and let's right click it. So the section name is 30 centimeter by 40 centimeter column. So using this and the shear reinforcement data, we are going to design this column that is all the longitudinal reinforcement plus that of shear reinforcement or transverse reinforcement for final detailing. Let's open the Excel template sheets. Proceed to input all data from ETABS output. So material property, from this we have two material property. The first one is that concrete grade. So using all this drop down menu, let's use let's input this data as C30, and that of steel grade, let's use this drop down menu again. So let's use S500. So using all this data, the software automatically calculates the characteristic, yield strengths, design yield strengths, and so on. So let's move down to input all the column geometry. From this dimension selection mode, we have 3 choices in the drop down menu: the standard one, custom, and manual. Let's use the standard one. As I told you before, the column width and depth, that is the column section, is 30 by 40 in centimeters. So we have a drop down here, so you can input like this. After that, the basic point is that the typical story height, that is 3 meter. You can edit it again, or you can input any story height. And the maximum required reinforcement area, that is from the ETABS output, it's 1200 millimeter. Let's check it. That's good, 1200 millimeter. After that, let's proceed to the longitudinal reinforcement calculation. ETABS output required area. This is the data we have entered before from ETABS output, and the basic point from this is that selected longitudinal bar diameter. I have select any diameter of bar using that of the drop down menu. Let's use diameter of 40, and number of longitudinal bars, I have to fix any number of longitudinal bar by comparing or by adjusting this and the final provided area of reinforcement. So let's check 8 diameter of bar. That is actually good, but it's nearly that of ETABS output. So let's increase it in someone, but you can use as it is. So let's use 10 diameter. So it says pass by comparing area of reinforcement, that is the minimum and maximum from Eurocode standard 2. So let's proceed to the next, that is the development and lap length calculation. Lap location, from this we have two basic choice, that is at the floor level for the workmanship purpose, but it's not actually correct. This is because Eurocode standard fixes that our lap must be at the mid of the column, that is staggered each other. So for workmanship purpose, let's use at floor level. Basic required anchorage length, it's a basic part from this that enable us to calculate the developed length at the footing and that of the required lap length. So the basic required anchorage length is calculated as reinforcement that we have select divided by 4 times that of design yield strength divided by that of FBD. So using this formula you can calculate it. So our basic anchorage length is like this. After that, let's proceed to the developed length at the footing, that is the anchorage length for the foundation column inside the footing with 135-degree hook. So you can multiply it by 0.7, or you can use 70% of basic required anchorage length. Required lap length, to calculate the lap length, we have two choices. If the lap is at the midsection and if the lap is at the floor level. So if the lap is at the midsection, you have to multiply that of basic required anchorage length with 1.5 and 1.4 for that of floor level. So using this, you can calculate our required lap length. After calculating this lap length, you have to consider, or you have to compare it with 5 times diameter of bar and 4 times diameter of bar for both compression and tension. Let's proceed to the next, that is transverse reinforcement design, or that of shear reinforcement design. For the shear reinforcement design, we have two basic region, that is a critical region and that of non-critical region. This is nothing but, if we say critical region, that is the region at the top and bottom of the column, and non-critical region, it's located at the middle. So let's calculate it one by one. Let's check first ETABS output data for that of shear reinforcement area. So let's go back to ETABS. After that, let's go to the design menu, concrete frame design. From this design information. So let's change the design output as that of shear reinforcing. So make it okay. As I select this foundation column, the shear reinforcement is 645 averagely, and the other is 0. So for this shear reinforcement, that is 0, we have to provide minimum and maximum spacing by referring Eurocode standard at both the middle and the critical regions. So let's proceed to doing this. Let's go back to the Excel template sheet. So our ETABS output is 645 for that of area of shear reinforcements. After that, the basic point is here. That is the minimum diameter required. From this, the minimum required diameter of bar for shear reinforcement is maximum of 6, and that of diameter of bar, that is 40 divided by 4. You can get our minimum tie diameter. So from this, let's select transverse reinforcement. Let's select it as 8. So you can use also a 6. The other basic point is that the hook length for that of shear reinforcement. So for the hook length, I have to multiply the selected bar diameter with 10. You can get this amount. Let's proceed to the next. The critical region. From this, you can select any ductility class. That may be ductility class low, medium, or high. So in our case, let's use ductility class medium. Critical region length for top and bottom of the column. This is the basic point. All of you must give attention here. In most cases, I have to divide the column into 3 parts. That is L over 3. After that, I have to use the top and the bottom as the critical region, and the middle, that is L over 3 part, as non-critical region. This is actually not economical. You have to calculate all the critical and non-critical region lengths one by one. So let's calculate it. For the critical region length, lengths at top and bottom. So I have to use a maximum of the column depth and that of the column floor heights divided by 6 or 450 millimeter. So using all this value, you have to take a maximum of this. From this, the templates automatically take this value. After that, data spacing in a critical region. This is the basic point. So from this, let's check first the maximum allowable spacing in critical region. So in the critical region, if it is ductility class medium, I have to select this. That is 6 times diameter of part, that is 40, comma that of 0.6 times the column width, and you have to compare it with 175 for ductility class medium and 125 for that of ductility class high. That is the maximum level spacing at the critical region is automatically calculated by this template as 84 centimeters. So you have to use a minimum of this. Let's use 80 millimeter spacing. For the non-critical region, that of critical region length, that is at the middle. So as we know, the critical region, you have simply subtracted. And the next basic point is that the maximum level spacing from Eurocode standard. So the maximum level spacing is that minimum of 20 times 40, that is the bar diameter, comma that of the width of the column, that is 300 millimeter and 400. So by comparing this, the Excel template sheet select this value. After that, you have to provide the maximum level spacing, that is minimum of this number. Let's use 250. So this is all about the multi-floor design parameters, all the floor datas, and this is obtaining more than a checklist that the template automatically checks. After that, I have to calculate the input data. So let's calculate it. After that, let's check the final design summary. So this is all about the final design summary that I have get. So you can send this to the draftsmans. This is all about today's tutorial. Don't forget to subscribe this channel, like this video and share to your friends. Let's proceed to the giveaway. I will share this Excel template sheets for all of you if this video gets 100 like and 100 comment. Thank you family. Have a nice time. Goodbye.